Enzymes are proteins that speed up chemical reactions by lowering the activation energy. You should be able to recite that by the end of this lab. So again, we're working with catalase, right? So remember, potato smoothie, the enzyme that's going to break down hydrogen peroxide into water and oxygen. So in this experiment, what you're actually going to be looking at is how pH is going to be affecting how enzymes work. So again, remember, enzymes have a quaternary structure, right? They have a 3D structure that is going to help them be functional. And if you mess with that structure, you mess with the function. So we're going to be testing our catalase in 3 different pHs, right? So the first pH is a pH of 3. pH of 3, remember, is an acidic pH. That acidic nature is measured by how many hydrogen ions are inside of this solution. The second pH we're going to look at is neutral, right? So neutral pHs are going to have an equal number of hydrogen ions and hydroxide ions, which is basically the purest water that you can possibly get. And then we're going to look at a basic or alkaline solution with a pH of 11. This is going to have less hydrogen ions and more hydroxide ions inside of its solution. So in test tube 1, I've put in our pH of 3. In test tube 2, we've put in a pH of 7. In test tube 3, then, a pH of 11. And then I've added about 1 ml of our catalase solution from the potato into each test tube. They've been sitting there for a little while. So now what we're going to do is add in the hydrogen peroxide. Can an enzyme that has been exposed to these pHs still work, is basically what we're looking at, right? So we're going to use our hydrogen peroxide, add in a couple mils here, again, kind of gently to make sure there's not a ton of turbulence that looks like a reaction when it's actually not. So we're going to put in about 2 mils, about the same amount. I got a little bit of air bubbles going on here. In here, give them all about the same amount. And then in lab, what you'll do is you'll measure these after about 20 seconds using this beautiful ruler, which is not called a calculator, even though that's what I called it earlier because my brain hurts. So what you can actually see even happening now is that in each one of these environments, the enzyme is working a little bit differently, right? So in a pH of 3, which is that acidic environment, the enzyme isn't really working at all, right? You have almost no bubbles that are forming here at the top, a little bit, right? So which means that the enzyme is not functioning in a pH of 3, that the pH of 3 has interacted with the hydrogen bonds of our enzyme enough that it's basically started to denature and its function isn't working as well. Now again, remember, we're working with a potato, okay? So potatoes are different than humans. All organisms have their own optimal environment. So here, what we are seeing is bubbles being made. So if we line these up perfectly so their fluid levels, I got a little bit off. It looks as though the pH of 7 is more effective than our pH of 11, but the pH of 11 is still working. Again, think we're talking about potato, and the potatoes grow in soil. Soil is often a little bit basic in many environments or many parts of the world. So we see some activity for the potato, actually quite a bit really, which would be different if we saw it in other organisms, right? Like in humans, our pH is about a 7. Our enzymes have an optimal environment of about 7. We would not work as well in a 3 or 11 because our enzymes would denature. The potatoes did denature at 1 in the pH of 3. It did not denature in 2 or 3, but it is working more optimally in the 7 pH than it is in the 11 pH.